Good morning, students. We have studied about the Laplace transformations of various functions and various properties of the Laplace functions, and also we have studied the Laplace transformation of derivative of functions and the integral of the functions. Today we discuss about the Laplace transformation of the functions with multiple of x and its powers, and the Laplace transform of a function with a division of x. So first, the Laplace transformation of function with division by x and its powers. That is, not division. First we discuss about the multiplication, then division with the product by x and its powers. That is, we have to find the Laplace transformation of x raised to n fx with respect to p, and this comes to be equals to minus 1 raised to n dn upon dpn of fp, or it is equals to minus 1 raised to n fn p. We have to prove this result. So proof of this result comes from the definition of the Laplace transformation. As we know that the Laplace transformation of a function fx, we have denoted this by fp, and this is equals to, by definition, integral 0 to infinite e raised to minus px fx dx. If we differentiate it with respect to p and apply the Laplace theorem or Laplace rule of differentiation, under the sign of integration, we get first differentiate equation first with respect to p. So we differentiate it as d by dp of fp. This is equals to d by dp of integral 0 to infinite e raised to minus px fx. As we know that differentiation of fp is f dash p. So f dash p is equals to differentiation of integral. Here we use the Laplace theorem of differentiation under the sign of integration, which shows that this is equals to integral 0 to infinite del by del p of e raised to minus px fx dx. Differentiation under the sign of integration comes to be the partial derivative inside the integral sign. So differentiating partially, we get integral 0 to infinite minus of x e raised to minus px fx dx, or we can write it as minus of integral 0 to infinite e raised to minus px into x fx dx. On the right hand side, we see that integral 0 to infinite e raised to minus px x fx dx is nothing but the Laplace transform of a function which is x fx. So we can write it as minus of Laplace transformation of x fx with respect to parameter. So here we get, this implies Laplace transformation of x fx with respect to p is equals to minus f dash p, or this is equals to minus 1 d by dp of f number 2. From this we see that equation second shows that the result which we have to prove, equation second shows that the result is true for n is equals to 1. So we will prove the result by the principle of mathematical induction. We will prove the result by mathematical induction. So assume that the result is true for n is equals to n. So we get the Laplace transformation of x raised to n fx with respect to p is equals to minus 1 raised to n dm upon dpn of fp number 3. Again, differentiating equation 3, differentiating 3 with respect to p and using Laplace rule under the sign of integration, we get the Laplace transformation. First we write this one as the Laplace transform. First Laplace transformation of x raised to m. First we write in integral form. We get integral 0 to infinite e raised to minus px x raised to n fx dx is equals to minus 1 raised to n dm upon dpn of fp. Now differentiating this with respect to p and using the Laplace theorem, we get, differentiating this with respect to p, we get d by dp of integral 0 to infinite e raised to minus px x raised to n f of x dx is equals to minus 1 raised to n dm plus 1 upon dp m plus 1 of fp. Solving this, we get differentiating of this integral and using the Laplace theorem, we get integral 0 to infinite del by del p of e raised to minus px x raised to m f of x dx is equals to minus 1 raised to m dm plus 1 upon dp m plus 1 of fp. So we get here it is minus integral 0 to infinite e raised to minus px x raised to m plus 1 fx dx is equals to minus 1 raised to m dm plus 1 upon dp m plus 1 of fp, and this is equals to integral 0 to infinite e raised to minus px x raised to m plus 1 fx dx is equals to minus 1 raised to m plus 1 dm plus 1 upon dpm plus 1 of f. The left hand side is the integral, which shows that this is the Laplace transform of a function x raised to m plus 1 fx. So we write it as Laplace transformation of x raised to m plus 1 fx with respect to p, and this is equals to minus 1 raised to m plus 1 dm plus 1 upon dp m plus 1 of f. This shows that the result is true for n is equals to m plus 1. This shows that number 4 shows that the result is true for n is equals to n plus 1. So we have proved that the result is true for n is equals to 1. We have assumed that the result is true for n is equals to m, and we have proved that the result is true for n is equals to m plus 1. So this result is true for all natural number n. So we use the principle of mathematical induction. We can say that the result is true for all n. So this implies by mathematical induction, by the principle of mathematical induction, the result is true for all n. Hence, the Laplace transformation of x raised to n is equals to minus 1 raised to n dn upon dpn of fp. So this was the Laplace transformation of multiplication with x of a function. Now we prove the Laplace transformation of a function with division x. We prove the Laplace transformation of fx upon x with respect to p is equals to integral p to infinite f u d. The integral p to infinite f u d. Proof of this theorem: let gx is equals to fx upon x. We assume another function gx which is equals to fx upon x. So this, from this here we get fx is equals to x gx. If we take Laplace transformation of both the sides, then Laplace transformation of fx with respect to p is equals to Laplace transformation of x gx with respect to p. As we know that Laplace transformation of fx with respect to p is fp. So this is equals to fp, and the Laplace transformation of x gx. X gx is the product of a function gx with x. So Laplace transformation of a function gx with the product of x, as we have studied in the previous result, we know that this is nothing but this is equals to minus 1 raised to 1 d by dp of Laplace transformation of gx with respect to. Now integrating one with respect to p from p to infinite, we get integrating first with respect to p from p to infinite, we get integral 0 to infinite, integral p to infinite fp dp. This is equals to minus of integral p to infinite d by dp of Laplace transformation of gx with respect to p dp. So this is equals to Laplace 1 minus Laplace transformation of gx with respect to p, and the limits are from p to infinite. Or we can write it as, the left hand side can be written as integral p to infinite fu du. This is equals to, the limit of this one is minus limit p tends to infinite Laplace transformation of gx with respect to p plus limit p tends to p Laplace transformation of gx with respect to p. As we know that the Laplace transformation of gx with respect to p, when the limit p tends to infinite comes to be 0. So, and by putting p tends to infinite in this one, we get Laplace transformation of gx with p. As we have taken gx as fx upon x, so this is nothing but this is Laplace transformation of fx upon x with respect to p. So from here we get Laplace transformation of fx upon x with respect to p. This is equals to integral p to infinite fu, which is the Laplace transformation of a function fx with the division of x. So Laplace transformation of fx upon x with respect to parameter a, p is equals to p to infinite fu d. So today we have discussed the Laplace transformation of the multiplication or the product and the division of a function with x. So we get these results, and in next time we will discuss about some more property of the Laplace transformation. Thank you very much.